foundation of that information or foundation of the data. Okay. So let me execute this. Another two packages, as I mentioned, is important. So for those who are not from data science background, may not be aware of these two. So pip install --user Matplotlib. Okay, so Matplotlib is for plotting the graphs, and after that you need to install another one. Sorry, pip install --user of Seaborn. Okay. Seaborn is for advanced level graphical visualizations, which helps you to give you a understanding of, like, Matplot is very simple. Okay, just x-axis by x. With Seaborn you can add a lot of different visual effects and a lot of different other stuffs which are very important to kind of do the analysis at a larger scale. Okay, so these two packages, you need to install it. I do already have it, so I'm not going to install. I'll just put it at the top. For those who wants to code along with me, can install this. Next is import Seaborn as SMS and import Matplotlib. Matplotlib dot pyplot. It is a class. Okay. Pyplot as period. So these are our packages that we needed. Okay. And we are executing it. Let's see. So every time we do aliasing with all these packages, otherwise every time you need to write Seaborn dot plot, okay, or Seaborn dot histplot, Seaborn dot blah blah blah. So every time you need to write that. So for that reason we use aliasing. Okay. Anything else? I think not required at this stage, because we are just going with analyzing the information. That's it. So now let me read the data. Okay, so HR data, right? So HR pd dot read underscore CSV. But before that, let me understand whether it is a CSV file or yes. What kind of file? XLS, worksheet. It means it is a CSV. Yeah, it is a CSV file. Okay. So if you're reading a CSV file, then .csv, and if you're reading Excel, then read Excel or XLSX. Okay, any one of them works. I do need to take the path of this. Okay, so because this data is in my local folder of a different folder. Okay, so I will carry this path. So copy as path. Okay, and then I can put it over here. Okay, so HR data dot head. The first thing that I want to see how the record looks like, right? So this is our records. Just imagine the scale of the record. Five rows, because head represent only top 5 values. 35 columns. Okay, so all the details related to that particular employees are present over here. Okay, so we have the employee number, duration, age, then okay, we have all type of information, like whether it is an iteration, yes and no. Okay, and then we have the age, we have the business travel. Okay, So everything almost is present over here, like okay, all the information almost, and 35 columns are. So we can basically do this, take this data and figure out what are the different what are the different insights is present in this given data. Okay, so mostly so next is we want to see that how big this data is all about. Eventually you can also see from tail, hr-data.tail, and the other way is checking the shape, right? So you can see that 2939, which is quite less in terms of data engineering project, and eventually in any AI and data science. So anyway, this is just a sample of information. This data will basically help us in creating a lot of insights about the data. So 2939. Eventually, you can also see the shape. So HR data dot shape. So this tells me that 2940. Okay. So this is our 2940 rows and 35 columns. So one important aspect whenever we are dealing with pandas, okay, the first value always represents rows, and the next value represent columns whenever we are dealing with pandas. Okay. So this is what the shape tells us, that it's near about 2900 data rows and 35 columns. Next is the both way is feasible. You can check the tail. From here you can see the index, or you can check the shape. From here you can see 2940. The next stuff is how many of the data. Now data has a lot of different characteristics, and that is why we are learning pandas, is to capture those characteristics. Okay, so the first part is understanding how many of them, how many of these data, okay, or how many of these data are basically continuous data or categorical data. Okay, little bit of understanding on this continuous and categorical data is basically continuous information, right? When you are saying a continuous data, okay, continuous means that there is some numerical representation. Okay, numerical representation. On the other hand, if you see it from data science perspective, continuous data is being referred as whether that data can be broken into multiple sections or not. For an example, it has two meaning. Okay, one, in terms of data engineering, we define continuous data as any numerical representation. In terms of data science, we represent continuous data as a different meaning. Like if you want to buy oil, okay, you can buy it at any given level. You can buy in form of liters, you can buy in form of grams, you can buy in form of milligrams, right? So you can basically bring it down at a different levels. Okay, so yes, it is possible. Let me put it over the Slack. Just a minute. Hmm. Yeah, you can now avail it from Slack. I've uploaded it, and I guess okay, I'll do it later. Yeah, thanks. So from Yeah, I was talking about continuous data. So continuous data has a different meaning in both the different fields. In terms of data engineering, we present it as a numerical or integer or a float value. Whereas in terms of data science, it has a more precise meaning. So oil is something that can be broken into liters, into grams, into milligrams, okay, as further as you can break down. But you cannot break eggs. Can you say that I want half egg or 1/4 of the egg? You cannot buy in that way, right? So that these data you cannot include into continuous data. Okay. So in terms of data science, okay, this is in terms of data science, not in terms of our designing of data engineering. Here we just classified, okay, the other side of the data is basically the categorical data. So it's mostly the categorical data. Now, what does the categorical data says? Categorical data. So it's mostly like male, female. Okay, it has some categories, some discrete values, okay, true, false. 0, 1. So these are the categorical representation. So when you design any database, okay, you need to understand your data first, right? So let's say you have somewhere around 100 plus columns. So as a data engineer, you need to go through all of these columns. Is it feasible? No, right? Like 100 plus column, 10 plus tables. When the data scales, you need to handle a massive amount of data. Okay. Basically, that's the job of data engineer. So at that instance, it is very difficult to figure out which are the categorical columns, which are the continuous values. Okay. So it's very difficult, right? So what you can do is, because based upon that, you need to design your database. Okay. Where do you need to store string values? Where you need to store your integer values? Okay. So what you can do is the best part, which I follow, and eventually the industry follows. Okay. That's the best practice. Okay. You have a pool of data in your warehouse. Okay. And you just take some portion of it. Okay. And check what are your attributes. What are your attributes? Means basically what are the different type of data present in that, and you can check that with the help of pandas. 3,000, like the data we have 3,000 almost. So what we can do here is to check how many of them are belonging from what kind of data or data structure. Okay, so we can easily go with HR .info. So this tells me many things. First of all, continuity of the information. Some of the tables might have only selected information. Not all the values are filled up. So over there, you might get some null value. You can see non-null count. Okay. So this is kind of a check. Already Pandas is doing in a fraction of a second, where you don't need to put any of your brain. Just see and get the insight of how the data is all about. So you can see these are some objects. Okay. So objects in the sense they are not numerical information. Okay. So they are being referred as an object because pandas treat it is as an object. Mostly these are string related data. Okay. Like some text contents present. So you can see these are the objects, objects, again objects, objects, objects. So this tells me, okay, and I'm very clear with this, that there are 9 objects and integer 26 integer means 26 columns which has integer values, and there are 9 object columns. Okay. This is making very specific, right? Yeah. So this tells me that what are the different data types we have. Okay. So these 9 objects, okay, and out of this, they may be categorical, may not be categorical, because we don't know until we see the data. Okay. So we need to figure it out. Okay. So how will we understand? Now there are 35 columns, 9 objects. So let us pull out all the objects. Okay. So let us pull all the columns. So HR underscore data dot select underscore data types of all the objects. Object. Okay. So I am doing what? All these are all our data types. So I am selecting object out of this entire data. And columns dot all the columns. I need to see those columns. You can see that iteration is object business travel. So I can easily, I got all these column names, okay, out of this information. And these are our object related data. Okay. Now, I want to also see these data sets. So eventually what I can do is HR data. Okay. So I can now visualize all the object data. Okay. Now let us now select that whether all these data are categorical or these get data are not categorical. So let's take this one first. At iteration, I can see only yes and no. So this is obviously a categorical data. Now coming to business travel. Business travel is also a categorical information. Department, sales, research, development. So department, there can be 4, 5, 6 departments. So categorical information is there, but it is beyond 2 or 3 categories. Okay. And even that is also taken as a category. So this is also a categorical. But one important aspect, then, like, there should be some grouping. Okay. If there is no grouping, you cannot take it as a categorical data. For an example, name of a person. Can you group name of a person? Can you group name of a person? No, right? So not every text value is a categorical. You need to select first. Okay. So here it is very easy to figure out with the help of pandas. We are exploring the data first. So these are our data which are categorical. Education field, you can see life sciences, others, medical. There can be a number of categories. Okay. Gender is obviously a categorical data. Okay. This is also category, male, female, others. Job role, it is also fixed. A company has a fixed set of job roles or fixed set of roles, basically. Okay, not everybody is given with an individual role, right? So, job role is also category. Marital status is obviously a categorical value because it represents the category. Overwriting, yes, no. So this is also categorical. Overtime, this is also categorical, yes, no. So mostly all these data are categorical data. Okay. So what we can do is, in spite of this object, we can replace this object with category. So how do we do it? For I in columns and then data HR data of I, okay, is equal to HR data of I dot as type category. Okay. So what we are doing is we are changing the objects into category. So as type means we are changing the type, means we are defining the type here. Okay. So we are converting these objects into category. Let me execute it. So this is the for loop that we are writing it up. Okay. So for every columns, okay. So this column is being referred over here. Okay. For I in the columns, calls dot column. So what is calls? This is what where we have all these indexes. This is basically the column list, and we are changing that into category. So let us execute this. So now you can see HR data dot info. Now you can see that all them are now converted. All of these are converted into categories. Okay. That is fine. This will actually see there is another observation as well. The memory utilization. If you see the memory utilization, object has more memory to capture, whereas category takes less memory. Okay, because it is mostly the binary information. So in order to increase, okay, in order to not increase, sorry, decrease the memory usage, we actually convert the data into category. Now, these are very minute stuffs which we need to notice. Why? Because these will only scale when you have a large amount of data. Okay. When you have billions of records, this memory usage will be impacting factor of your data. So in terms of, in order to reduce, it's generally used for bigger data. So what I will do is, I will put a comment over here. So in order to reduce the memory size, we converted all the objects to category. Okay. So this will help you when later on when you go through this entire data again once again. It will help you to kind of understand why we changed into category. Clear? Any questions so far? Anybody, any doubts, any question?
Yeah, can you just go back to the up top where we started? I just want to follow the procedure in terms of importing the data and going through the command. Is that possible?
Yeah. So yeah. This part you are talking about importing pandas.
Yeah, and then after the read and then the data head tells you what now, and then the tail.
So over here, first observation is we didn't make any observation, okay? Just to see like how much big the data is initially, and then later on going into an understanding that how many columns are there, what are the memory usage. You can see the memory usage when the data is storing in form of an object is high. So we converted that object into category. We also understood how can we understand categorical data, and that's what our memory usage went off, like went down. Now we will see like what are the different aspects we can measure this information, what all we can explore out of this data. We will see now going ahead. Any other questions? Just a minute, guys. Okay. So now let's move on to the description of the data, like what are the different scales that we have it, what are the different aspects, like from the numerical standpoint. Categorical already we have seen, and there is we will also kind of emphasize on the categorical data, like how many records are there, what are the different categories, okay, how it is splitted. We'll see that. Before that, now let us bit explore on this numerical parts. Okay, so let's do that. So first of all, how can we explore the numerical data set? So HR data dot describe. Okay. Let's see. I need to scroll. So what I will do is I will use transpose. When I transpose this, all the columns get into rows. So it's easy for me to kind of analyze. Okay. So employee, now you can see the age. Okay. So the average is 36, whereas the minimum is 18 and maximum is 60. Okay. And that is what is quite natural in any of the employment. Okay, 60 is your target year or the retirement year. Okay. Then you have the daily rates, okay, which is again starting from 102 to 1499. There might be this daily rate might be in dollar or any given value, mostly in dollar. Okay, seems like daily rate is mostly in dollar. And distance from home, okay, 1 to 29. Okay, so everything is being given over here. These are the quartiles that we have it. Okay, 0 to 25, 25 to 50, 50 to 75, 75 to 100%. So for most of these information, we have this range. Now this range will actually help us to set our database parameters or the attribute values. Like what should be your limit of information that you want to store. So anybody, like for this age, let's say this age. So what we can do is like anything which is greater than 60. Okay. Anything which is kind of greater than 60, we can drop that record. Okay. Probably that should be an error. Okay. So we can set up those limits in our database. Okay. So that no such false positive information, or you can say false negative information, get entered into our data. Okay, so we can set those limits from understanding these limits from the information currently we have it at a different source. So you can see data distance from home. There should not be any limit. Okay, there should not be any limit for distance. Daily rate, there should not be any limit. So we will see like which all the information should be limited and which all the information can be scaled, like year on year it can scale. Like total number of stock level or stock option levels. Okay, so this is something that has certain limits. So like that, we can identify monthly income max has been an error. No, that is not the case. Monthly income max can be scaled at any level. I'm saying that age, okay, like anybody going before 60, okay, let's say 61, 62. If the organization is following those rules, okay, and then we can we can drop those, we can treat those as an error while punching in this data into database. But here there is no such information which is greater than 60, it is all up to 60. I'm saying that while we design a database, if in future we are going to accept anything, then at that point in time, we can create these logics. And this is something that has to be worked with who are experts in business domain. So this is with HR now. Professionals or the business domain leader should also kind of endorse these logics before we put this data into our database. But again, not everywhere we put this logic, as I mentioned. This varies, like daily rate. It can be anything, right? It can scale with given time. It can be inflated with given time. Cool. So these are our data, and we can see there are a lot of different scales that are present. Okay. Now there are some information which depends, like based upon your project. Okay. So some of the information is required, some of the information is not required. Like it depends on what you are trying to build, what is your end goal. Okay. So you can drop some of the columns like employee number, something that might need it, okay, in terms of basic analysis, but in terms of predictive modeling and all of those, when we focus into more into data science, at that point in time it is not much required, right? So from data engineering perspective, we are not going to drop any such columns, okay, until unless we need to drop it. But as of now, I'll just go to the categorical data. Okay. So HR data dot describe include category dot transpose. Okay. Transpose is just to shift them into rows to column to rows. Sorry. So you can see this is very interesting part. Okay. See the number of classes present. For job role, there are 9 different classes present. Okay. And it tells me the top frequency. It's the top most important class, which is sales executive, with 652 records present out of 2490, right? 2940, sorry. So 652 records out of 2940. Then you can see that most of them are married. Okay, means you can just imagine the population is a little bit mature. Okay, just an assumption. Yeah. So iteration, there are 2 type of data. Okay, 2 type of values. Yes, no. So the unique represent the number of categories present, and the top values are basically we can see that iteration no means probably that person have joined in a different business unit or something like that. Business travels, there are 3 type of travel. Rarely, most of them don't travel. Okay, so you can see that 2086, which is a very great population. Department, research and development, most of them are into that. Okay. Education field, most of them are into life sciences. 1212. Gender, most of them are male. So yeah, these are the job roles. So this tells me that most of them don't they are not interested, or they don't do overtime. Okay, so no, most of the majority of them. Over 18, yes, we have seen in this mean also that the age is minimum 18. So all of them are over 18. So that's why 2940. Okay. So data is quite intact and quite in relation. Okay. So you can further calculate the percentage and all of those. Okay, like you have this, and then you can take this count, okay, frequency by count into 100, and you can easily plot the percentage. You can add a column over here, okay, just to show you. So these are our counts, and eventually you can call these columns. Okay, then the last one is basically, let me check what is the last column. So it is frequency. So you can eventually go and call these column as frequency. Eventually these are our frequency. So what we can do is we can store this into some random variable, and eventually without storing also you can do it, but that is a bit complicated. And if you see, this is our data, and at the end you can write %, which is equal to frequency first, and then divided by count into 100. Okay, so can you put them into places? So you can see the percentage over here: 83%, 70%, 65%, okay, 41, 60%, 22, 45, 100%, 70. So like this is the way we actually, any information that we want to immediately count and or calculate, what you can do is you can create a column here, okay, and we just add that. That's it. Any questions? Like if you want to, moving to something more, if you want to see both of them, yes, no, both of them, okay. So what you can do is like you can run a loop which will go through every categories of those categorical variables. Let's say for iteration. So what my loop will do is it will come to iteration and it will break down into yes and the other part is no. So it will go and count how many yes and how many no. Because from here we can understand pretty much. Eventually from here also we can calculate. You can, you don't need a loop, okay. The optimized way would be subtracting this with this, and that's what you know, okay, right? 2940 minus 2466, that is no, and that is more efficient than creating a loop, right? So that is what I would basically, but this is fine with two categories. But what happens if I go with this 9? Okay, so there is 652, that is fine, but these 9 individual categories we don't know, right? For 2 it is fine, for 1 it is fine, and 2 is fine, but for 3 and greater than 2 we cannot count in that way. So just check first that if all the unique categories are 2 or 1, then eventually you don't need to run a loop. You can just create a column like this and subtract from the total value minus 246. That will make more sense. But if you are having more than 2 or 1 categories, at that point in time you need a loop. So eventually you can optimize your overall computation. Okay. So anyway, let me show the loop part. So for I in columns, so before that, let me store all the categorical columns. So columns under category is equal to data dot select underscore d types, and here you punch in the category. Okay, so this is all the categorical data. HR data. And if I want to see this variable, actually see it over here. So these are all our categorical information already present. Okay. Now what I will do is I will navigate through each of these categories and figure out how many categories are there, and then I will get all the details. Okay. So there is two ways. One is going through all these attribution, iteration, business travel, and calculate the value counts. Okay, so what we are doing here is, let's say, column category of iteration. Attrition. Okay, column category attrition dot value counts. You can see no 2466 and yes 474. So this tells me that how well the data is kind of into different categories, spreaded across categories. Now what we can see, what we can do is we can run the same thing in a form of a loop. So for I in columns category dot columns print unique values in these categories are as well as are these are pretty basics, but tells you, will give you a lot of information about how these things are going to work. So you can see that unique values in iteration are no 2466, yes 47. Then next is unique values in business travel are travel rarely, okay, 2086, okay. I will come to the question. So travel rarely, travel frequently, non-travel 300, and then research development. Blah. So these are all the different categories. So you can see this, okay. Then unique values in marital status, over 18, over time. So these are all our categorical values which are already represent. And this will basically gives you an understanding, gives us an understanding like how the data is spread across. Okay. But if it is more in a picturized form, then it would help us in a better way, right? So let us see that. Okay. We will now go and create some plots, and with the help of that plots, we'll understand. Let me go through this question. Okay, as a data scientist, I know some columns have same value, which won't give any meaning to the model. Correct, but as a data engineer, I shouldn't remove yes. So what should I do if the same person do both? Okay, so I know probably removing them later, yes. So what you have to do is like the basic way, like if you are handling end to end, okay. So this is your pool of information. Okay, you can treat it as a warehouse. Okay, and you first create, you first analyze your warehouse, what kind of data you are having it, analyze this, and probably after analyzing, you have to create two tables. Okay, so we as a data engineer, we create two tables with two different levels of schema. So you can say L0 schema, and then you can create L1 schema, and you can create multiple schemas on top of it, L2. So L0 is basically your primary data, which you are dealing with right away. Okay, which can have a duplicate records. It is kind of the raw information. L1 is basically mostly it is cleaned information, like as you have mentioned that the data which you don't want it or the data which you want it. Okay, so L1, now this can be referred as kind of a database asset properties, which I will again come into the data phase. But in real-time engineering, what we do is we create these different schemas of information. Okay, the schema can have a repetitive tables. It can have multiple tables, table T1 till Tn. Okay, table T1 till Tn. So you can create a table which is more kind of utilized for your machine learning project or a data science project, okay, where you can take this information and pass on to your models, predictive models. Now every model has a different meaning, like every data has a different requirement, right? So that you can create in your notebook, basically means in your Python environment, okay, and then probably you can take that into your predictive modeling and get your results. So this is how you can do it. So in your L0, your primary data is preserved. If it is kind of needed to use by a different person or a different department, can utilize the same data. And in the L1 stack, you have more customized information. In L2, it can be further customized. L3 can be further customized like that. Thanks. Okay, moving on to, so this is our data and these are our records. Now let us do one thing. This is mostly we practice the same thing in data science, and we will be practicing the same thing over here as a data engineer as well, because this practice of exploration will help us to understand the data in more detail. So this is the first, this process is known as exploration or explorative data analytics. Okay. So we, in a short form, we call it as EDA. Okay, EDA. So let me put it as a heading. EDA. EDA helps you to get a better understanding of your data. And based upon that, you can solve multiple queries as well. Okay. So these queries can be any given queries, like it can be a business query, it can be possibly any ML related queries, and most of the time data engineer won't do it, but at a times it might require. Okay. The data engineer would limit himself until this information is out. Okay, what are the different data and what is the structure, and probably you will also check something more like checking the null values. Okay, so HR data dot is null dot sum. So this will probably help me to understand how many null data is there. And if you want to understand the total null data, again do the sum. Okay, so this tells me that there are 0 null data in this. And there is another which is not applicable. So HR data dot is NA, okay, dot sum. This tells me that how many not applicable records present. So null of them. So only this much of information basically will help us in understanding the data. But if you want to go beyond some basic understanding of the data, or if you want to pull some, sometimes what happens, like we don't need any predictive modeling. So at that point in time, you might just need to kind of answer a few business questions, okay, from the information. So not every time we build, we create a database, it is just a one-time activity, right? So it is not like the organization hires everybody just to do that one-time activity. So EDA, why I have included in this, basically helps us to get into more detail of the information where we can answer many business questions. Okay. So before that, let me, so EDA is basically using, it's for plotting, and will kind of explore all the data and will plot that data accordingly. So let us plot the information. So first of all, we create a function here. So we have studied a function in our last sessions, how to create function. So we'll be creating the function over here. So that every time when we plot a graph, We don't need to write that code again and again, Okay. So these are some of the real utilities of your Python. So let me write histogram box plot. Histogram box plot here, couple of information that we will pass. Okay. First of all, we might pass data. Okay, means the records, means the entire table we can pass. We can pass some columns. Now in data engineering as well as in data science, these are mostly known as features. Okay, the columns can be treated as features, means these are having some potential to give us some predictive results. Okay, so that's why we call these as features. Okay, so what we will do is we will try to pass the features as well. Not every time I need an analysis of entire data. Let's say I want to understand that whether there is any dependency between age and hourly rate. Is it like the experienced guys are earning more and the initial entry level are earning less, or is it based upon talent? Okay, like anybody can an experience or can an entry level who can solve the problem can earn more. Okay, so there could be different objectives. Okay, right? So if you want to kind of pull those kind of information, so you don't need all the columns, you need only respective relevant features. So data comma features comma figure size. So some of the time, sometimes what happens, like fixed size is basically telling me that how much big area we are taking and then plotting the data. Okay, so let's say we are taking 12,7. So what is this 12,7? 12 is the width and 7 is basically the height. Okay, so this is being referred as figure size, means when you are plotting anything, how big that information is all about. So fixed size, so is equal to 12,7. And then KD is basically kernel density estimator. This I will explain a bit later. This is nothing a part of it as a data engineer. We don't bother even about this. But KD is basically creating a kernel density estimator, which helps us to create a density maps. Okay, understanding that how the data is associated and create a density map. Probably we'll see in the later phase. As of now, not required. So bins are basically, this is a histogram plot. Okay, so in histogram, what is histogram? Basically x-axis, y-axis, and these are our plots. Okay. Right, so these are basically known as bins, each and every individual boxes, or you can say each and every individual house is being referred as bin. Bins, we can tune it if we want to see that whether the data is well populated or less populated, how the data is populated. So based upon that, we can adjust the bin. Okay, so bins we will adjust is at times. So that's the reason I'm writing none, like if required in a different based upon different histograms, we'll create these bins. Okay, and then colon. Now here we will basically create a we'll write the code for plotting the values of the graphs. Okay, so first part is basically subplots. Okay, so Matplotlib is basically helps us in plotting these graphs. Okay, the first part, when we say subplots, subplot means I can have multiple different plots. Okay, means I can have two histograms plotted together. Okay. Three histograms plotted together. Okay, n number of histograms plotted. So these are subplots, or I can have multiple different plot codes. Like let's say somewhere I am using histogram, somewhere I am using a different other plot, okay, scatter plot, okay, a combination of multiple plots. So in those cases, we use the concept of subplots. Okay, so subplots means it's not only one single figure, but two different figure. Okay, two different plot. So here, what I have planned is what the way we are going to plot the graph is mostly like this. We will take a histogram. Histogram will basically tells us that what are the different levels the data is merging. And on top of it, I want to actually plot a box plot, which tells us the scale and the range of information. Okay, means over here in this box plot, it will tell me that what is my mean, okay, what is my mean, and what is the majority, means majority of the information coming in to the box plot. Okay, we will go into those explanation in more detail once we plot this. But this box plot tells you basically the range of information. Okay, at the same time, it helps us to understand what are the statistical parameters. Okay, so both the things it helps. It's basically a descriptive form of your statistics. It also tells me that whether it is well spreaded or whether it is skewed data. So these are some of the data science related stuff, should not be merged with data engineering, but just a part of, and just trying to give you some flavor of how things are in real time. Like these are not every time we do it as a data scientist or every time we do it as a data engineer. It is kind of on demand based when you are dealing with a large project. Sometimes you have an access to the information directly, you can pull the data and put it. Data scientists work on more specific problems rather, okay, like they want to predict. So they work on the model building mostly. They want to understand which feature to select. They do all those stuffs. But here it is more like what features you have in your information. Sometimes just answering the business question. So I will keep this diagram over here, and we'll be getting into more detail of how this has to be coded. So there are two things, two portion of the code. The first portion is this a box plot, which will appear on top of this histogram. Okay. So let me write the code and then I will explain. Box 2, ax underscore histogram, which is equal to plt dot subplot. Number of rows is equal to 2, means number of rows of subplot. Okay, once I execute, you will basically understand, and I will be able to relate these hyperparameters with that. So here x is equal to true. This is basically x-axis. This is our x-axis. Right? This is our x-axis. So x-axis plotting. So share x, and this is our y. So y is not needed across this particular box plot. Okay, we just need to share the variable, whichever variable we are using here in our histogram. The same variable has to be shared over here in our box plot. So that's the meaning of share x. And then we will go with grid space, grid spec, grid specification under k, which is equal to height ratios. So this is basically nothing but when we are creating those grid is basically nothing but where we are plotting those bars. So there should not be a case where your bar is having, let's say, there can be a point where a particular data having a very low scale and a particular data is having a very high scale. But if you can't measure this difference properly, if you don't put this difference properly by optimizing your y-axis, then what happens is like you cannot differentiate the difference between this level and this level. So what we are saying that height ratios 25:75. Now this becomes very easy. 25:75. This becomes very easy to match up the ratio, like very easy to understand, right? Similarly, with the help of these plots as well, when you are putting multiple plots together, you need to adjust your plots. So that's it, nothing else. 75% of this is your histogram, 25% of your plot is box plot. Similar thing we do with grid space of grid specification on a particular chart. Okay. So yeah. And finally, what we will be doing here is fig size. Fig size is equal to fig size. So whatever the fig size is basically the size of the overall figure. Okay. So 12/7. Okay. 12 rows, 7 columns, like that. So these are the specification of our subplot. Now we will create these plots. So SNS Seaborn is a high level package over the Matplotlib, which helps us in beautifying, you can say, the plots, as well as adds a lot of other different plots which is not available in Matplotlib. So C1.boxplot. Okay. So data is equal to data. The data which we will be passing in our function, the same data will pass over here, comma, x is equal to all the features. Whatever the features we are passing, we will be passing this in x, right? And ax, which is basically the box ax box 2, which is this particular subplot, means first is the box plot, right? So it's basically telling me that the different position levels. Okay, so box 2, comma, and do we need to show the mean value? So show means is equal to true, comma, color is equal to let's say violet. Okay, so these are our features. Means this is how we can create a box plot. Okay, so SNS.boxplot. Okay, this is the data. This is the data. This is the feature. This is basically the positional change. Like if you are creating in a subplots, you might be creating multiple box plots as well, multiple histograms as well. So this helps us in naming that. Okay, what would be your position? And then show means is equal to true, which means that you want to show the mean value of your data. So true, color is violet. Okay, next is we need to do the same thing with histograms. Okay, so SNS dot hist plot. Okay, SNS dot hist plot, where again we can take the data is equal to data, comma, x is equal to features, comma, x is equal to features, comma. In histogram, as I mentioned, the bin size or the bin width changes rapidly. So what we will be doing is we take KD, kernel density, means how dense is your data. Okay, it shows the density curve. Okay. By default, it remains false. So KD comma KD, which is next AX is equal to AX underscore histogram 2, comma bins is equal to bins. Okay. Palette is equal to winter. So there are different palettes. Basically, you can come over here and you can write Matplotlib color palette. Just a minute, guys.
Hi, Rishabh, are you talking? I'm not able to hear you.
No, he stepped away for a minute. He said just a minute.
Oh, okay.
Yeah, sorry guys. Any questions? Anybody? Okay. So let me show you this color maps. Okay. So color maps is nothing but the different scale of colors, and you can see you can choose any of one of them. Okay. Basically, these are easy to remember: winter, autumn, cool, hot, copper. So any of these color map you can choose it, and the top ones are also kind of used, but little bit difficult to remember everything. There's nothing to remember. You can anytime refer back to this particular Matplotlib, and there are a lot of examples here as well, how to create the different type of graphs. Okay, what are the different graphs you can create with the help of Matplotlib. So I will come to this later on. Okay, let me go over here. So this is what we are going to plot. So yeah, I have taken this palette color winter. Now we need to check. We need to kind of bean is currently none, but if beans are if we don't want beans basically, okay. If you want to customize the beans with some different lines or something like that, okay, there are multiple type of graphs are present. Okay, so what we can do is we can write a condition here, like if beans else sns dot hist plot. Okay. Now, in spite of beans, what we can do is we can omit the beans section, and in spite of that, we can use a different lines. Okay, so I have to explicitly mention that with the hist plot. So sns dot hist plot. Let me take a line, and then I just copy entire thing, and then we yeah. So over here, what we can do is we don't need the beans, so we can skip this part. Palette also, I'm skipping, but you can keep it. Color doesn't matter. But why I've skipped palette is I want to create the different lines. So for that reason, I've skipped the palette. So next is as I have not added beans here, so I need to use the different lines, okay, in place. Okay. So this is more like, let me define this, ax comma hist2. This is our position, and we want to draw the line, axv line. Okay, and from here we can use data of feature, any given feature, okay, dot mean. Okay, we have to calculate the mean, and then we can color that line is equal to green. Okay, so what we are doing basically, let's say, other than beans, so beans are already created. Now let's say our mean value is somewhere here, so I need to draw a straight line corresponding to the mean. Okay, so this straight line we are drawing with, if it is not beans, in the else part we are writing SNS, which this part is done, this box plot is done. Now this line we are drawing, okay, so which is this hist plot, and we have taken the data, we have taken the feature density estimator and the location as well. But what we have to do is we have to explicitly mention that what kind of line we want to draw. It's a mean line or median. In terms of categorical data, it can go into modes based upon the count and presence, right? So let me use this. So that's why we are calculating the mean, okay, and coloring that line as a green color, okay. And eventually you can give the line style. So line style is equal to underscore means under dashed lines. Next is ax underscore hist2 dot axv line data of feature dot, if we want to calculate median, comma, color is equal to, let's say, blue. I want to give blue color for our median, comma, line is equal to, okay. So yeah, this is fine. So this is how we actually create a function, okay. And I'm not writing any return because everything we are plotting, so there's no need of mentioning the return here. Okay. Everything is getting plotted, so it's nothing we are returning here, but while this function gets executed, we will get everything in a plotted form. So let me erase this and execute this function. Okay, I got an error. Read spec. Oh, it has to be in curly braces, basically, this part. Okay. Let me execute. If else part, also we got an error. Cool. So this is our function. So I will again come to the function by plotting one graph so that it becomes easy. Okay, so the name of the function is histogram box plot. So we'll use this, and we'll come over here, histogram box plot, and we'll pass the data, comma, any feature we can pass. So first is, let's say, let's pass age. Because another important aspect, categorical data is different. Okay, like in terms of box plotting, we will actually use also, but before that, let us see the numerical records and figure out the relations. Okay, and later on we will see the categorical representation as well. Okay, so age. Let me execute this. Age data. Feature is not defined. Okay, so it has to be features. Okay, features. So now you can see. So this is our plot. Okay, so what we do over here is, first of all, this is age and this is count. Okay, the different values that are present. Okay, of different aged people. Okay, so 20 to at the age of 20, there are barely very less amount of people, whereas you get to see more people at the age of 30. Okay, 29 to 30 range, and these are basically referred as beans. Okay, so these are referred as beans, and you can see a blue line, which is our median line. Okay, so blue line is basically the median line, and you can see a green line, and it is much aligned. Let me draw and show you. This is much aligned with this green triangle, and this is much aligned with this blue line. So this line is basically median in box plot. So this is box plot, and this is hist plot, histogram. So over here, what we can see that this is our entire range of information, but mostly our information is between these interquartile range. Okay. Anything, so this is our range of information. Okay, acceptable range of information, and this is known as interquartile range. What is interquartile range? It is basically from 25. So you can basically define as 25 to 75% of the information is being present in these interquartile range, IQR. Okay, so 25 to 75. Okay, so the first is Q1, which is 25, and the last one is Q3, which is 75. And this is your minimum information, and this is your maximum. And if you remember, the same thing our pandas is plotting in its describe function, pandas describe function, right? 75, 25, much more with easy values it is plotted. Okay, in a fraction of a second, you are coming to know what is your interquartile range. Okay, so interquartile range starts from this position, which is somewhere around 25 in the center. This is the 25 percentile. Okay, but here, along with our data, let me write the data points over here, which definitely says that somewhere between 29 until somewhere between 45 to 44 to 45. Okay, So this is the majority of the chunk that your data is having. Okay. Interquartile range. Now, your this is basically defining my entire data. Okay, and this is how we can visualize. Okay, like majority of the chunk is present over here. With histogram, we can understand. With histogram, we are able to understand. So this is how the data is basically getting plotted. But if you see, the majority of them is being in this chunk. Okay, and that is what is your IQR, interquartile range. Clear? Any questions? Anybody? Now moving to some more parameters. Okay. So let's go to this daily rate because this is basically telling us that what is the hourly rate or not hourly, sorry, daily rate or daily salary value. Let's take this. So histogram underscore box plot, and then we are passing the HR underscore data, comma, daily rate. Let me check once. This is in a camel casing. Yeah, daily rate. Okay. So now let me execute it. You can see over here as well. That is your mean and median is the same value. Okay. That's the first observation. Mean is equal to median. Okay, so this is the first observation that you can find it over here. The other aspect is this is the entire range, and I don't see any outliers. Okay, there are some specific ways to determine the outliers, which I will speak once we get to see the outliers in the data. So anyway, we'll speak about that. This helps us outliers in the sense that is not at all required in our data sets. Okay. So using now, how can you map this with your different data engineering tools? Once you understand the data at a very deep level, this helps you to kind of build the query, optimize the table, okay, optimize your entire life cycle of data engineering. Okay. As I was mentioning that there are different schemas, levels, okay, level 0, level 1, level 2. So you can basically create those levels based upon the data that you have. So that's what at the first level we actually who designs this entire process as an architect will first understand in both aspects, from the data science aspect as well as from the engineering aspect. Cool. So this is quite flat. You can see there is no distribution. One, from the probability distribution, I can see this is basically a uniform distribution. Okay. This data is normal distribution. This is from the statistical analysis. Okay. But anything that is not much required in terms of this, because that's a huge again, a huge explanation is required. But just want to see, like, from as a data engineering perspective, we were seeing that is there any outliers present, or the numbers are pretty much intact from 200 to 1400, equally distributed. That is why it is uniform. Okay, so this is the curve it is forming. And if you see the above the age one, it is uniform. Okay, sorry, it is normal distribution. This is normal one, and this is uniform. Cool. So let us see some more results, okay, which will help us to understand the data at a different standpoint. Let me clear and select some value. Let's say distance from home. Let's take this data point. So histogram underscore box plot feature underscore data comma just a minute. So here we can see some news story piling. Okay, here the overall data is basically right skewed. Skewed means kind of heaping at the right side of the entire distribution. Okay. So something like this is happening. So your IQR is somewhere between 2 until this is somewhere less than 15, which is you can take it as 30. Okay, so 2 to 13 is basically your IQR. So most of the people live close to work, but we do have some employees that lives very distant apart. Okay, so this tells us that this IQR tells you that what is the most majority of them staying near. So 2 to 13 is basically the data that it is supporting, and majority of them are kind of staying away, okay, from the respective data point. Cool. So this is mostly a right skewed, okay, to the right hand side of the information. So, and also there is a substantial gap between mean and median that we have it. Cool. The next part is let's take some more data to analyze. Let's take monthly income. Okay, monthly income. So histogram underscore box plot HR underscore data monthly income. So here is an interesting fact here. Okay. But we can see that there are few new interesting visuals, which is this part. So this tells that somehow, apart from this 15,000 levels, okay, so this is basically your outliers. Outliers means has kind of very less in frequency, less in terms of relationship. Okay, so this you can treat it as an outlier. Okay, no, basically outlier removal and all, we as a data engineer don't do it just to understand that much. It's fine. Most of these are being done based upon the real-time analysis by data scientists, not at this stage. We basically try to preserve all the information. So we can kind of preserve this information that above these 16,000 levels, okay, most of this data is reflecting as an outlier. And also you can see that the data is well skewed on the right hand side. And majority of them is at this levels, okay, 2500 to this level, okay, which is somewhere near to 7,000. 7,000, yes, 7,500. You could take it. So this type of visuals helps you in understanding the data at a deeper level, as well as is helping me to understand what are our outliers. Okay. And so monthly, this is your monthly income. Okay. Now, if I want to figure out that whether this has any relation with the number of working hours, okay, or number of working years, means sometimes what happens, like some organization try to preserve some of their valuable employees. Probably for those employees, they might have increased the salary or monthly income is quite high for them. So how do you analyze those? We will take, let me go and check total working years. Yes, this tells me the experience of the employee. Okay, so let us plot it. So box plot, sorry, histogram, underscore box plot, and then you find push in the data. Data, comma. Yeah. So I can see some similar outliers which are present, like above 30 means above 28. Okay. So there are very less people, total working years. It's somewhere around this level. Somewhere around 29 to 30, okay, at this level, 30 years, okay, which is above that is basically an outlier. Very less amount of people are there. Okay. And probably, I'm not sure until we do the analysis, probably because of that reason, there could be a spike in the salary, okay, because the people who are working at this level of high experience, okay, so it's difficult to retain them or difficult to hold them because they need to be paid with a higher salary. So probably this could be the reason, total working years. But again, until we understand, we can't assume it, right? Until we plot this. So this is how you can go ahead with different type of visuals, which helps you to understand the data at a very deeper level. Next, if now this is individual, so this is basically known as when I'm taking only one particular feature, which is total working. So with this, it tells me this is known as univariate analysis. Okay, univariate means you are taking only one feature, expertising on that feature. Okay, so now let us change it. Let's make it a bivariate or dealing with multiple different other variables. So we will plot it. So plt dot figure fixed size, okay, is equal to. So let's plot a correlation matrix. Okay. SNS dot heat map data dot correlation annotation is equal to true v min is equal to -1 v max So I will explain you, don't worry. Let me just frame the logic. Formatting has to be between 2 decimal place maximum. C map is equal to color map. We can come over here and write C bond color map, color palette. Yeah. Okay, so these are the color palettes like flare, crest, magma, rocket, spectral. Let's use spectral. So anything you can use it basically. You don't need to remember basically, even though I don't remember every time. It's very difficult. You can just come and choose it from the color palette. Sorry, HR data. I every time forget this HR data. Yeah. So this is basically your correlation analysis. There are few variables that are correlated with each other, and that should not be anything that we are not aware of. You can see employee count. Okay, so this variable and standard hours, employee count. So these are blanked out. Why? Because these variable doesn't add any value. Okay. So if I want to see standard hours, so let me check. Yeah. Standard hours 2490. So all are 18, same value. So it's basically having no correlation. Now, basically correlation means what? How one particular monthly income is related with age. Okay. You have -1 to +1. Okay. Now -1 represent negatively correlated. +1 represent positively correlated. And you can see 0.0, which is a white color. That's what your standard hours has employee count, has no relation because 2940. What we are going to do with the employee count, right? So that's why we can drop this from this. We can understand that these are having no such features, no feature explanations. So there's no point of storing this level, this big sort of information. So we can eventually come and drop these rows and columns. Now coming to this diagonal is always equivalent to the same value. That's why it is always 1. Means it is same value, employee number. So you can ignore the diagonals, not required. Apart from the diagonals, the value that is showing, that makes a big sense. If you see these total working years, 0.68. Total working years is highly correlated with job levels, 0.95. Okay. Job level and total working years is 0.77. So if you see this part, let me locate it for you guys. Total working years and sorry, that is easy to visualize. So total working years and monthly income. Okay. Total working years and job level. Okay. Eventually this is also quite high correlation. The longer you work, the higher job level you achieve, and that is what is the job level says. The more time you spend in a company, you see this years at company 0.53. The more time you spend, the higher the job level. Okay, so years with current manager means more you are aligned with the current management or the current manager. In fact, they know you better, right? So if you are working for 2 years with your manager, the manager knows better like 2 years. Now let's say the other manager comes in, it's not sure about how much you have contributed and maybe not sure about what are your strengths, right? So again, it gets difficult. So this kind of story you can build it out. Okay, same over here. It happens with job level and age as well. So more the age, more the number of years of experience, total working years, right? More the age, more total years of working, and in fact, higher the job level. So it's kind of acting in this way as well. Okay, so eventually job level is at a good state, even directly relation with the age. But I'm trying to create multiple taking other columns and then analyzing it. Okay. Next is what are the other observations? Let me erase these lines. So to be more explainable in terms of this correlation. So correlation means, positive correlation means both sides is increasing, means age is increasing, job level is also increasing. Okay. Negative means, let's take some negative value. I don't think so there is any negative value. Yes, I can't see any red values. There are negative values like 0.1 to 0.19. So which is bare minimum, like near to the zeros only. Not much value. So you can ignore those. And I don't see any high negative value here. So not negative. Negative correlation means that let's say your age is increasing and your salary is decreasing, something like that. So it never happens, but yeah. So and that's how is basically here it is kind of vice versa. Okay, so one is increasing, the other is decreasing. Okay, no correlation means there is no change. Okay, means somewhere you are at these levels, there is no correlation, means neither of the values are changing. Okay, has no impact. Okay, so this is how you can basically do the analysis and understand like which other columns are important, where you need to kind of focus, and you can basically go ahead and inform the data scientist as well, like these are the columns where we need to stress on, these are the columns can be a fruitful. From here we can easily understand what are the columns important. Okay, these levels, these levels, these levels, then these are the points, right? These are the points, these are the points. So this is the correlation matrix. And like this, there are a lot of different charts that we do analysis. Probably I will be extending this tomorrow again. Okay, bit of it, but we don't need really much effort over here. Okay, to be honest, as a data engineer, we don't need much effort to do these visuals, to understand these visuals. But this is just an extra add-on to all of you to understand which are the columns important where, so that you can go ahead and plan and design the database accordingly, like which are the columns, like these are the columns which are having a relationship, maybe positive, maybe negative, but having some relationship. The other columns, hourly rate, it is uniform altogether. So that's why there is no relation. There is no correlation. It is altogether uniform. We have seen in our box plot in histogram. So as in no correlation. Sorry. So this is how you can do the analysis. Tomorrow I will be showing few things more, like taking X and Y column, putting two different feature and then see how the things are. And then we will jump into our SQL stuff. Okay. Probably from next week, we'll jump into SQL stuff where we'll get a more understanding of the tables. We'll do some more hands-on over there. Cool. Any questions? Any doubts? We are now open to it.